The inspiration for this particular presentation came from my humble beginnings as a DBA at IBM. I was in global services, and I was a physical DBA, which meant I dealt with backups and restores and extending table spaces and installing and upgrading and things like that. I don't think I wrote a single SQL statement for the entire first year I was a DBA. And when I went to do the first certification exam, the DB2 Family Fundamentals, it was extremely difficult for me because that exam is so focused on SQL. And these days especially, not so much then, but these days especially, there's a lot of SQL that we need to write as DBAs in order to administer our databases, in order to look at performance, in order to look at objects and understand what's going on in them. And so it's a skill that some of us who came from a similar background probably don't exactly have. Now, there are probably some DBAs too who came from the application development side who know writing SQL inside and out. For that, I've still got some good SQL at the end of this presentation. There's some helpful things that I use in administering my databases that I want to share. So Scott already told you all about me. I do have all over the presentation my Twitter ID. I tweet quite a lot, and also the link to my blog and my email address. And I love talking to DBAs and hearing what problems people have, what questions people have. I learn more from that than from anything else, so I'm happy to discuss things with anybody. So we're going to start out super, super simple here. This presentation, I start with DB2 basics. DB2 basics mean I start at a very basic level. But we do ramp up. We do get to some more complicated stuff later on. So this is a standard syntax diagram for the general form of our select statement. We start with the word select in every select statement. And then we tell we'll tell it what we're selecting. We'll tell it what we're selecting from. We can optionally add clauses to filter our data, to group our data, to order our data, and several other things that we'll work through here. So the general format of the select statement is very simple. We can start out with a star. The simplest select statement that we can do is select star from some table. And what this does is tells us, well, give me the whole table. I want everything. And that can be useful. I definitely use that in some situations. However, it doesn't tend to be the best formatting. It doesn't let us limit to just the columns we want to see or just the rows we want to see. It's also not the best performer, and we're not going to do a whole lot on SQL performance in this, but there are two reasons that it's not the best performer. It is going to return the entire table. So if you need a smaller subset of data, specify that smaller subset of data. There's less work that has to go on within the database in a lot of cases to return that smaller subset of data. And the other reason is when we are developing tools or when our developers are developing applications, select star will return whatever columns are in the table. And over time, the columns that are in the table may actually change. So we like to return only the columns that we want rather than doing a select star. After select star, we can narrow it down a little bit and show just the columns we want. So if we want just one column or we want just some subset of columns from a table, then we can select that. In this case, I'm selecting from syscat.schemata that lists all of the schemas within my database. And I want to see only the schema name itself. Maybe I'm looking for something specific in that schema name. So I can select just one column, or I can select a number of columns in order to get that data. The first way that I end up complicating my statements more is by adding functions, and these are usually for formatting. One of my favorite functions that you'll see in almost every query I write is substring. And the main reason is that if you issue a query at the DB2 command line, you're going to get the full length of whatever varying character field you might be querying. And that can be very frustrating for formatting. It can make it very difficult to read within a command line environment. But by using the substring function, we can specify a starting point within that string and a length within that string. And it will give us just that data. In this case, you can see I've done that. And what it does is it truncates to exactly that length. It gives me that 8 characters no matter what it has to cut off in order to do that. And that's important to know, so you're aware that when you pick a length, you might have columns that go over that length that would simply be truncated. You'll also notice at the top here, we see this 1 instead of the name of that particular column. And this is what happens with functions in SQL, because DB2 doesn't actually know what that function is doing. It doesn't know if we have fundamentally changed the meaning of the data being returned. And so it gives us simply this number that may not be all that informative. To get around that 1 or that 2 or however many columns you might have those numbers as the title for, you can alias your columns within the SQL itself. So the part that we've added in this statement is just this as BP name. And in that particular case, it will simply put whatever string we have specified at the head of that column. And that can be very useful to have in our formatting and to make sure that if we go back to that data later, we can understand what exactly that column meant to us when we wrote that query. You'll also notice here that I've increased the length so that I get the entire text here. Let's see. So the next function that I use fairly frequently is the decimal function. This can be very useful when you're playing with performance metrics and you're dividing and doing various things and you end up with a floating point number. If you query that floating point number directly, you might get E and scientific notation and a number that doesn't mean a lot without a little bit of thinking. But with the decimal function, what you can do is you can tell it exactly how many places on each side of the decimal you really want to receive. So in this case, I want to get, I've used for the precision and the scale. The precision is the total number of digits that you want in your number, no matter which side of the decimal point that's on. And the scale is the number of digits you want to the right of that decimal point. So in this example, you can see that I'm using a decimal on a hit ratio percentage, and I'm saying I want 4 total digits, up to 4 total digits. It will not add leading zeros to my numbers, but up to 4 total digits, and I want one of those digits to be to the right of the decimal point. And you can see all of my numbers are formatted in that particular way. We can also do math right in our column list. And again, this is something that is very useful when we're calculating things. This particular query here gives us in DB2, let's see, 10.5. This particular query is 10.5 because it's looking at column organized sizes as well as row organized sizes. This particular query is querying sysibm adm.admin tab info to give me the total size on disk that my table is taking up. And to do that, I'm adding up a bunch of different fields within that table, and I'm also dividing them to make sure that it's in the right format that I like. So in this case, I'm adding these different values, which may be the columnar object size, the data object size, the index object size. I'm adding in long, lob, and XML to get the total size of everything for that particular table. I then divide it by 1024 because that particular value happens to come to me in kilobytes, and I want it in megabytes. And I get a nice, easy output. I'll show you order by in a little bit, but in this case, it happens to be ordered by the size, so I can see my largest tables down to my smallest tables. And a side note, you may note here, since this is blue 10.5, you can see these SYN tables. Those are the synopsis tables. So this calculates data both for your base tables and your synopsis tables. Now, everything we've looked at so far gives us a value, some kind of value for every single row in the table. The functions that we've used are working on each and every row, and we will get a value for each and every row. In order to filter out rows and make sure that we don't get every single row in the table, we use the where clause. The where clause is something that lets us give a little bit more information to DB2 about what kind of data we're interested in. Usually we're checking to see if some column value matches some specific value we're looking for. So in this case, I am looking for a list of grantees and seeing whether they have connect or DB Atomoff. I want to know for each grantee, I want to know the grantee name, and I want to know whether they have connect auth, but I'm only interested in those grantees that have either connect auth or DB atom auth. So I'm checking here in my where clause simply to make sure that those columns equal those particular values. And one thing to note here, you'll see on a lot of my queries with UR at the end, it's simply a habit that I'm in. I'm at the point now where I will sit and type DB2 describe table with UR. Every single statement gets with UR. I actually had a friend wish me a happy birthday with UR last year. So. And the friend was not a DBA. So. So everything we've done up to this point has been on a single table. But a single table only gets us so far. There's a lot of data that we may need to join within the database. So we may need to bring data from two tables together and return that data in one result set. So there's a couple of different levels that we might be talking about join types at. The level that we're talking about here is what we're specifying in the SQL. We're telling DB2, do I want to do an inner join, a left outer join, a right outer join, or a full outer join? There's another set of join types that are chosen by DB2 to satisfy the query. And those are the join types that you're going to see in an explain plan. And these two sets of join types are not necessarily related. DB2 can choose several different kinds of joins. We're not talking about those kind of joins in this presentation. So what an inner join says is an inner join says, given two tables, give me the rows that have matching values in each table. Only the ones that have values in both tables. So in this case, we're looking at syscat.dbauth, which is a fairly easy one because it's one a lot of us have had to deal with. And what we're pulling from syscat.dbauth is we're pulling the grantee, the person who has been granted a privilege. We want to know if they have connect auth. And then we're also joining that to syscat.tabauth so that we can understand the permissions this user has on tables within the database. So we're getting whether they have select auth on the table names listed. So in this case, when we join the two tables, we're going to use the syntax from table name. And then you see this as, that's another alias. In this case, I'm aliasing the table name itself so that it's easier for me to refer to that table within the query. And then I'm going to use the keyword join. And I'm going to join it on tabauth. And then I give it what I'm joining the two tables on. What is equivalent in the two tables that lets DB2 know which rows actually do correspond. And there's another type of syntax for joins I'll talk about in a little bit, but I'm going with the explicit join syntax for now for the example. You can see in this particular case, I get two rows, and I see I have client 1 and client 2. They both have connect auth, they both have select auth, and it gives the name of the table that I'm looking at that particular permission on. A left outer join says, give me all of the data in the left table, whether or not it has corresponding rows in the right table. But in the right table, give me only the rows that have corresponding rows to the left table based on my join condition. And when you're thinking about it, the left table is the first table you mention, and the right table is the second table that you mention within the query. So I'm selecting the same fields. In this case, I'm saying left outer join instead of join. That's the only change in this syntax here is the left outer instead of just join here. And I'm joining on exactly the same column. And in this case, you'll see that I have 3 rows from my left table, and I have 2 rows from my right table, and I see simply dashes for the row in my right table that does not have a corresponding value in my left table. Does that make sense? Does anybody have questions on that? Okay, so a right or outer join simply flips what happens with a left outer join. The right outer join says, give me all of the rows in my right-hand table, and give me only the rows that match from the left-hand table. So again, this is only, the only change here is the changing of the word left to the changing of the word right. And you can see here that in this case, I get 3 rows from my right table, and I get only 1 row from my left table. Okay, and finally, I'm going to show you what a full outer join looks like. A full outer join says, give me all of the rows from both tables, no matter whether they match or not. So basically, give me everything, but correspond the values where they do match. So in this case, you can see I have my 2 rows where I have values in both tables. And then I have 1 row where I only have the values in my left table, and I have 1 row where I only have the values in my right table. And I've done a little trick in this query using a function I like called coalesce. And the main reason I'm using coalesce here is because I'm telling it to give me the grantee name from, if you look at the last query, I was telling it to give me the grantee name only from my right table. And if I do that only from my right table, then for those rows where I only have values in the left table, I won't have a value for that. I won't understand which grantee it's talking about. So what coalesce does is you give it 2 specific values, and it will return to you the first of those 2 values that is not null. So if db.grantee is not null, if it exists, then it will return that one. If if that is null, then it will skip and give you ta.grantee. And it's a very useful function for exactly this kind of work. Any questions? Okay. So there's a lot of ways to write any join, but there are 2 ways that we can talk about writing a join. And for many years, I was a fan of the implicit join. It seemed simpler to me. With an implicit join, you simply list the 2 tables in your from clause, separated by a comma, and then your join condition goes in your where clause. It seems simpler when you're first starting. It's one place to put conditions. But it's a little bit less clear when you think about it. And when you get into more complex queries, it makes more of a difference. With the join syntax, we use the join keyword between the 2 tables. And then we don't necessarily have a where clause, or if we do, our join condition is not in that where clause. Our join condition is under this on clause. And what this does is this separates out our join condition. It makes it so that it's very clear what's our join condition versus what might be filtering. It makes it so that for our filtering conditions are kept separately. And the advantage here is if you have a much more complicated query and you're playing around with different filtering conditions, you can easily remove those. But if you have your join condition mixed in with them, it can be easy to accidentally remove your join condition and end up with a Cartesian product, which is obviously not a scenario we want to be in a lot of cases. It's also easier because we can change our join type if we want. It's a lot easier to go from a left join, an inner join to a left join if you're specifying that explicit syntax. Okay, to get even more complicated, we can use subselects or subqueries within our main query. What subselects or subqueries are is basically a query within a query. It allows filtering on criteria that is independent of the main table being queried, or independent that is dependent on the relationship between the tables and not just on one table. Every join can be written as any of a join, which we've already seen, a correlated subselect, and a non-correlated subselect. Now, I'm not saying that I can write every join this way, because this gets complicated. If you talk to somebody like Dan Lexitich, he is a wizard with SQL, and I'm sure that he can write every single query any one of these 3 ways. But there are some queries that you can look at to understand how these different ways of writing it can work. Subselects can also appear in multiple places within the query. They can appear in your select list, they can appear in your from clause, and they can also appear in your where clause. So I want to go through these 3 ways of joining tables so that you understand how exactly the same results are gained from these 3 different ways. Now you're going to see exactly the same results from these 3 queries because that's the goal here, 3 different queries with exactly the same results. So this is the syntax that we've been talking about. In this case, I'm actually looking for table spaces that contain tables with columns with lobs in them. So it's a little bit of a complicated question. It's fairly likely something you have to ask. I want to know what table spaces have lobs in them. There may be different characteristics that I want to do with my table spaces based on whether they have lobs or not. So in this case, I am taking syscat.tables and I'm joining it with syscat.columns on my tab schema and my tab name. It's not a very complicated join, but I've got a clause where I'm looking for a type name for the data type of my column of either blob or clob. And because I'm querying syscat.tables, I got to make sure that I'm looking at only tables. I don't want to look at views or aliases. That could confuse my results. And of course, with UR. So the second way that we can do this exact same query is using a correlated subquery. And in this case, my subquery is in my where clause. So I'm selecting the same column. In this case, I'm selecting it from syscat.tables. And then I'm using a subquery to get the information from the syscat.columns. And I'm saying select 1 because I actually don't, this is actually an existential subquery. I laughed the first time I heard that name because it sounded strange to me, but it just means I'm checking for the existence of something in another table. I don't actually care about the data from the query, but I just want to know if it exists. So I'm doing select 1 because I don't care about the data, I just want to know if it exists. From syscat.columns, and you see here where I am relating this syscat.columns back to my outer table, to my syscat.tables. And I'm making sure that my tab schema and my column, my tab schema and my tab name match the same table that I'm querying from my outer query. And you'll see I get exactly the same results from this query as I did from the other. So the part that makes it correlated is that I am referring to the outer table within the subquery. Now, a non-correlated subquery is very similar to the correlated subquery, except in my inner query, my subquery, I don't reference the outer table in any way. So in this case, I'm selecting my table space from syscat.tables, where the combination of tab schema and tab name is in this particular query. Select tab schema, tab name from syscat.columns, where type name in these particular values, and the condition for the table type of T as well. Now, this is, there's another thing I want you to notice here where I'm querying for 2 values. I'm not looking for necessarily just 1 value. You can look for just 1 value, but this is a little bit of a less common syntax that I refer back to every now and then when I need to remember how to do this, so I can look for 2 values or multiple values in a subquery instead of just 1. Now, the next question that people might have is, which one of them performs better, right? And the answer is the ubiquitous, it depends. You really have to test. If you're looking at a performance scenario and you're trying different join types, you really have to test. There's not one clear answer to this one is better and this one is worse. Any questions on that? Mm-hmm. Are they? Okay. So did everybody hear that? He said that exists is more costly than others. But I do think it depends. I do think there are situations in which it would not be. So other uses of subselects. This is an example of using a subselect within the column list instead of within the where clause, as we just saw. In this case, we are looking for the count of indexes on by table within a database. Another very useful query that you might be using. You might need to know, okay, what table do I have that has too many indexes? What tables do I have that have a ridiculous amount of indexes? So I'm looking, I get the table schema and the table name. You can see it, that comes from syscat.tables. But then in this case, to get the index count, I'm selecting the count from syscat.indexes, and this is a correlated subquery because I'm referring to the outer table within the inner table. So, what's that?
So it is equal to a join or not?
It's a what?
Is it equal to a join? Like
Yes.
you said 3 times?
So, well, it is in a way, but think about how you would write this as a join. It's a lot more complicated to figure out how to write this as a join. And that's one of the reasons I like it better as a subquery. A lot of times when we're working with data, we need to put things in the proper order. It's great to give me the count of indexes by table, but what good does it do me if they're in some random order and I have to scan through a list that could be 1,500 tables to find the ones that are large or small? So ordering places the data in a specified order. You can order the data across only one column, or you can order the data across multiple columns. The columns specified in the order clause can be referenced by number. I'll show you that in a little bit. And you probably don't want to order the data unless there's a very good reason for it. Ordering the data is generally going to cause a sort, which again may be a performance issue. A lot of times when we're doing some of our administrative SQL, if we're not baking it into scripts or if we're not baking it into ongoing maintenance, then we're not worrying as much about that sort of thing. But it's always good to have in your head, if you don't need to sort, don't sort. So the order by clause goes after the where clause, and it's quite simple. In this case, I am simply using the similar queries as to what we were looking at on the authorities earlier. And in this case, I'm ordering by grantee. Maybe I need to look at different clients and see them in a reasonable way and get information about what sort of permissions they have on the database. And you can also, you notice I've specified ASC here. That tells to sort in ascending order. You can also specify descending order. The default, if you specify nothing, is ascending order. Now, we also have fetch first n rows only. And what this does is it limits our output to a specified number of rows. This can be good for performance. It can be good for returning only the worst offenders. There's a lot of places in which this can be useful. It's very frequently used with order by, so we can say, oh, give me the top 10 worst as far as this metric goes. Give me the top 10 largest tables, or whatever that may be. You should generally also use it with optimize for n rows. Depending on versions, there are definitely places where DB2 does not assume optimize for n rows when you specify fetch first n rows. And you also need to be very cautious with using fetch first one row. I've actually seen a situation where developers in a subquery, they needed a subquery to return only one row to match some requirements of the query. And so they said fetch first one row only. But the query that they had written was so terrible that it was doing a Cartesian product. And yes, it returned only one row, but it did this massive, expensive query in order to return that one row. So you have to be careful with using the fetch first however many rows in an application kind of situation particularly. This is an example of the fetch first however many rows. In this case, I am getting table sizes and ordering them from largest to smallest. You'll notice that the order by clause is included here. I have order by 3. And that means I'm ordering by the third column I'm selecting. Why do I use 3 in that particular situation? Well, I don't really want to type all of this all over again in order to do it. I can also refer to it by name in this particular case. But I can I can refer to it by number to make it shorter and allow it to be easier to handle. And then you can see the fetch first 5 rows only. I only want to see the 5 worst tables in this particular case. Okay, so we talked a little bit earlier about some functions that are used for formatting our data or purposes along those lines. There are also functions that are used for aggregating data. So some of these are very obvious. They're things that we use frequently, things like count. Give me a count of how many rows are in my table. The darker ones here are in brown are the ones that I use most frequently. Average count, min, max, sum, standard deviation, and also the list ag. And I'll show you a bit about the list ag in a minute because it's one of my favorite functions in DB2 to give me the data I want. Some of these others may be a little bit more obscure. You may not use them as much, but it's definitely good to be aware that there are a bunch of aggregate functions out there that you can use over groups and sets of data. The whole point of an aggregate function is to take some group of values and return a single number. Whether that group of values is over the entire table, such as count star, select count star from some table, or whether it's over a defined group using the group by clause. You cannot mix aggregate functions and values unless the values are what is being grouped on. And I'll explain that in a little bit more on another slide here. So the simplest form of an aggregate function, like I said, is simply selecting count star from a table. In this case, I'm simply counting the number of tables that are not volatile within my database. You can also use count to count the number of not null values, which can be very useful. In this case, I am finding tables in my database that don't have a statistics profile. If you're using automated statistics in some way, a query like this could be very useful to you to find what tables you don't have a profile set for. In this case, you see I have the name of a column within parentheses after my count statement, and that's what tells it to say, look in this column for values that are not null and count. Now, it's very useful to be able to collect items into groups to apply aggregate functions. And one of the biggest things I do this with is when I look at statistics on a database. I come into a database and I want to know how do run stats look in this database. It's a fairly important performance question that we end up needing to answer on a variety of environments that we may or may not have real detailed scripts available to us on. And in this case, what I'm doing is I'm grouping by the date on stats time. So what I'm looking at is for each date, how many tables in the database had run stats done on that date. And I'm using, so I've got the group by there in order to make my aggregate function work over that. And notice that I'm not selecting anything else here. The only things that I'm selecting here are the thing I'm grouping on, date, stats time, and the aggregate function. And you can see down here, this database probably has a problem. I have a large number of tables with no run stats at all on them. So. If you try to refer to a column that is not grouped on or does not have some sort of aggregate function on, this is the error message you will get, SQL 119N. And it will what I've got here is I'm telling it, hey, give me the table schema and the table space and the count of all tables. But that doesn't work because if I'm counting the number of tables by table schema, then they might be in different table spaces. So this table space is what trips it up here. It doesn't work in the concept of the query. Does that make sense? Okay, common table expressions. Now this one is definitely a bit more advanced. But common table expressions are exceedingly useful. They may be a bit scary the first time you see them, but they're very useful. There's a number of different ways that you can make use of them. Common table expressions are essentially a temporary table that you're creating within the context of the statement that you're running. They do not persist across SQL statements, but they are excellent for aggregating data and describing the parts of the data in terms of the whole of the data. They are part of the SQL standard. This is not unique to DB2. They are part of the normal standard SQL. They're placed before the SQL statement and essentially referred to the same way that a table would be. A common table expression takes this format. Before your select would be here, or down here. Before your select, you use the with keyword, and then you give your table a name. So in this case, I have with sum tab as, and then this select statement here defines my common table expression. It defines my essentially temporary table that I'm going to refer to in this SQL statement. And then after that, after I've done my common table here, then I use in my select statement the name, I can use the values from that within the name of the, and I have an error here. It should say, I should have in my from statement, I should also specify the name of the summary table. So you can see here that in this particular case, what I'm doing here is I'm selecting from the package cache. And within the package cache, I want to know for each statement, relative to all of the statements in the package cache, what percentage of the CPU used by all statements was used by this particular statement. And that helps me identify my worst performing SQL statements. It can be done across multiple metrics, but this particular one is on CPU time. So this bottom value here is going to calculate what that percentage. And let's go to the next slide so we can see the results. So I have the first few characters of my statement here to make it fit nicely on a slide. And then I have the total CPU time, but I also get a percentage of the total CPU time. And that makes it a lot easier for me to see, okay, so these are pretty bad statements. I mean, this one statement represents 33% of the CPU used by every statement in my package cache. That could be a significant problem. The other way that common table expressions can be used, or one of the others, is in recursive SQL. And I'm not going to go into recursive SQL here because it makes my brain hurt. And it's a little bit beyond the scope of this. But it's another place that you might commonly see common table expressions is to use recursive SQL. Now, the merge statement is something that you're normally going to make more use of when you're developing an application. The merge statement became available in DB2 10.5, FixPack 1. And I've got a link to a good developer works article on it here. The merge statement, what it does is it lets us tell DB2, here's some data that I want to put into a table. If it's not there, update it. Or if it's not there, insert it. If it is there, update it. And there's some other actions you can do with it as well. But what it does is it saves a check ahead of time. Your application no longer needs to check and see, is this row there? And then decide whether to do an insert or an update. So it's a little bit lighter weight. It can take different actions depending on the data and how you code it. It can do the insert and update. It could also do a delete in some scenarios depending on what it finds and what you tell it to. And it can also return an error message to the user if there's a value that doesn't match up with what you're looking for. In other RDBMSs, this could be similar functionality to what they call insert from, upsert, replace, or insert on duplicate, update. So the general form of a merge statement, we specify first, we say merge into, and this first value here is the merge target. That's the table that we want to insert our data into, or change our data that exists in our database that we're trying to do something with. Our merge source is next, and our merge source can be a table, can be a subquery, that can be from a nickname through federation. It can be a lot of different things. We then specify a merge join condition. So how do I tell if a row from my source matches up with a row from my target? You can then go through a series of operations and say, when some condition occurs, this is what I want you to do. So when it's matched, then I want you to update it. When it's not matched, when I don't find it, then I want you to insert it. Now this is an example of a merge statement. This is the only SQL in the entire presentation that is not against system views or system tables. I could not make it work to figure out something to work with on that, mostly because you're not usually changing your system views. Not usually. So this is simply an example from a client that was trying to merge data. This was actually coming from an Oracle database through federation into a DB2 database. So I have merge into eCrooks.einstance. That's the target. That's where my data is going into. And then I'm telling it the source, which this is a source table. It happens to be a nickname to a table in an Oracle database. And I'm telling it what matches up, what makes the rows equal between the two data sources. When it's matched, so when I find one that matches, and my target date is less than my source date, meaning that I don't have that data, that data has not been, has changed, that data is different. Then I want to update it and set these two values to those two values. When it's not matched, then I want to go ahead and insert. Okay, now I wanted to share some of the useful administrative SQL that I've been working with. And a lot of this is shared on my blog. I've got a series that I've been doing lately called the DB2 Administrative Cookbook. And it's simply the fact that I've been saving off queries that I use, that I like to use, and I thought, hey, I should share these queries. I have a blog, right? And that's what it's for. So finding how current statistics are. This is one I showed earlier in the presentation, simply looking by date, how many tables had run stats on that particular date. And this query is great for showing up missing run stats in a database where something has been significantly delayed or there aren't run stats done when they should be. Finding statistics times on a list of tables. Sometimes there's a very specific list of tables that you're looking for details on. And this shows the same syntax I was talking about before, where you have two values that you're looking for in a list. But this time it's simply looking for those values in an in list instead of in a subquery. Finding Problem SQL. This is my favorite statement at the time. Yes, it's very complicated. What it does is it looks for certain key performance statistics. So down here is where it's really looking for. It's looking for things where the percentage of rows read for this particular statement is greater than 10% of the rows read for all statements in the package cache. It's looking for the same for CPU time, exec time, any of these key statistics. If one particular statement is consuming greater than 10% of what all statements in the package cache are consuming, I want to know about that statement. And I do limit it here to the first 20 rows, but I've actually found that I don't ever end up with 20 rows. Most of my databases, I end up with 8 or 10 real problem statements, and the rest are not within this thing. This is the same syntax, and I'll show you the results in a moment, but this is the same syntax, but works on older versions. So the first statement was 9.7 and up. This will work all the way back to 9.1. The difference being that in 9.7 we got the mon-get package cache statement. This particular statement goes against sysibm adm.snapdine.sql to get the same data. If you're older than 9.1, I'm sorry. So listing tables by physical size. This is very useful and again has different versions for different versions of DB2. The main difference being here in that 10.5 we had to start calculating the columnar object size in with everything else. There were fewer things that we had to add together back in 9.1 through 10.1. This is SQL that I use to write reorg statements when I'm following the IBM recommendations of the reorg check, which I heard earlier has not changed all that much in the last 20 years. So it's when you're following those recommendations. What it does is it actually uses concatenation to write the reorg statement. It looks to see if there are clustering indexes, and if needed, it will do the reorg on that clustering index. If there is no clustering index, then it will not specify an index. And it looks, you first have to call the reorg check TB stats procedure, and all that does is generate reorg check information in a tabular format in memory, or not in your specific session. Not available to other people's sessions, not available to anybody else, only available in the session you're currently connected with. And so then you can look within that for the star, the flag, indicating that the table seems to need a reorg. And I also put a limit on the size of the table, making sure that it is not an empty table, because those tend to need a lot of reorgs because of the geometry of tables and stuff. So not need, they tend to show they need a lot of reorgs, they do not need the reorgs. And this is what I use for reorg index statements. I'm still playing with this one a little bit. I'm not 100% happy with it. I'm not handling F4 the best, the F4 formula the best in all of these. But it's easy to alter either of these reorg statements to meet your own guidelines. I know Scott has different thresholds that he likes to see. It would be easy to look at a specific calculated value for any of the functions that are the values that reorg check returns F1 through F8, and have your own threshold with these statements. List ag. I love the list ag function. I don't use it a lot, but when I need it, it is the best thing there is. So what list ag does is it's one of those aggregate functions we talk about. And what they do is they take a bunch of values and they consolidate it down into one. And what I'm using list ag here for is to create a comma-separated list of all the columns in a table. And this can be useful if you need to query it in some way, if you need to provide it to somebody in some way. Instead of having row, 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 row for each column, you have them all in one value with commas in between them. There were some ways to do this before 9.7 Fixback 4, using some XML functions and so forth. It wasn't terribly fun, but it's much easier now. What you can look at the syntax here, and you're grouping, you're listing the column. In this case, I'm ordering the columns by column number as well, so I get them in the order in which they are within the table. And it's a little bit of a complicated syntax to spend time with, but once you get it down, the list ag is very excellent for aggregating values in this way. You don't have to, at one point you had to use recursive SQL to get this, and now you do not. So that's it. Any questions? Anybody? So, not in this presentation. I think that's a little bit beyond the scope since this was a DB2 basics. I think there's definitely a place for analytic functions. And I think that there's certainly, they're very useful in some situations. Yeah, there you go. And there will be a query posted tomorrow on db2commerce.com that's another useful administrative SQL that I like to use. Yeah?
Not really a question, a comment. You mentioned the merge.
Mm-hmm.
My ETL developers love that merge. And one thing to watch out with that is that there's no way to commit it in the middle. If you're running against a big table, it's good.
Yes, that's a very good point. There's no interim commit for merge, and in a lot of situations I've seen it does perform slower than a simple import it would even, certainly than a load. The situation I described where I had seen it from an Oracle database with Federation, it was slow as a dog, and they went away from it. So. In temporal tables, it functions slow as well. Okay. Anyone else? Okay, thank you.